about to show you is our distributed control system, our Simtronic simulator. Essentially what it is it gives you real process distributed control system simulations, anywhere from fin-fan units to distillation towers to coolers and compressors. And it runs through simulations where a process upset can happen, something breaks, something goes wrong, and we have to take corrective actions to control it and get it back under control and get it within our operating limits of what we're wanting. This is a air cooler unit. It's essentially a fin-fan unit, and we're going to be taking a process in, cooling it through our fin-fan unit, and running it out at the set temperature that we want. In this fin-fan unit, we have our two fans blowing air from the bottom to the top to cool the incoming process, which runs in a sense through these red lines and comes out at a colder temperature of 120 degrees when it's coming in at 200. So we could do anything from condensing steam to cooling oil that's coming out and been compressed from a higher pressure. When it gets compressed, it becomes hotter, so sometimes you have to run it through coolers, cool it down. And after about a minute, something will start to go wrong, and I will have to correct it. Okay, and it's starting. I don't know if you can see, but our air temperature was initially 68 degrees, and it's starting to kind of drastically drop. We're already down to almost 60 degrees. So as you can see, our cooling tower, that will cause cooler air to run through it, which will be lowering our desired temperature from 120 probably down to, who knows, anywhere in the 90s range to much cooler. There's a few options I can do. I can close louvers and just keep the fans turning, or with this extra cooling that we now have and everything completely open, I can maximize efficiency and decide to increase my flow rate, which I click on this valve, which controls our flow, and through this I can turn our set point, which is at 130 gallons a minute, and type that in as, let's try 150 here as we're increasing. It's running fine and the process is doing good, and I just have to wait a second until it decides it's going to start changing something on me. Okay, now my set point is at 150. We're still below 120, so I'm going to increase my flow so that more process is flowing through faster and not cooling as fast, and will still come out at our desired temperature. Okay, so now I've changed my set point to 175 gallons per minute to help increase flow residence time, or decrease it so it's not cooling as much now that we have colder temperature. And as you can see here, my temperature is about 120, 121, back to where it was. The temperature has now dropped to 25 degrees and we're holding steady about right there. So it seems to be holding pretty steady. I'm just going to make minor adjustments from there. We're about where we're needing. So I've essentially corrected the problem, and now our process is flowing at the right temperature, going out to wherever it is. And in a way, I've also increased productivity by having more process and flow coming through, so more can be reheated or used in whatever it's going to be next down the line.